Hi everyone, this is our introduction to the bonding unit. This unit is really different from our work on gases. It's a unit that basically has very little math in it and only exposes us to a very specific part of the periodic table. For all intents and purposes, this unit is about molecular compounds, which means we're going to be working with compounds composed only of nonmetals. And sometimes we're going to see hydrogen acting as a nonmetal. More than that, noble gases don't form compounds, so we're not going to see them in any question. And we're unlikely to see some of these really larger elements down in the bottom part of this section. We're not really going to see astatine or tellurium or even arsenic. So, as we work our way through the unit, we're going to be doing questions with not very much math that only include hydrogen, boron, carbon, nitrogen, oxygen, fluorine, silicon, phosphorus, sulfur, chlorine, bromine, and iodine. Maybe once in a while we'll see selenium, but barely ever. So we have a unit with not very much math, and that only works with around 10 or so different elements participating in molecular compounds. The things that we're going to build off of from our experience in Science 10 that we're going to use in this unit are these three ideas: period, group, and total electrons. So the periodic table has periods, no kidding. The periods are the horizontal rows. That means there's 7 periods on the periodic table. If we take a look, 1, 2, 3, 4, 5, 6, 7. These horizontal rows are the periods. What a period represents is the number of energy levels, the electron arrangement in the atom by energy level. So hydrogen has 1 energy level. Over here, boron, carbon, nitrogen are in the second row down. They have 2 energy levels. Silicon, phosphorus, sulfur, 3, 4, and iodine down here in the 5th period would have 5 energy levels. That's not a big thing for us because the number of energy levels doesn't have much to do with the way that atoms are going to combine together to form a compound. Much more important than that is the group. The group are the vertical columns on the periodic table. There's 18 vertical columns on the periodic table. These are arranged by the total number of valence electrons. And that means the number of electrons in the outermost energy level. The thing is, the number of valence electrons, it corresponds to not exactly the group number, but it corresponds to the number in the ones position of the group number. This is a little bit tricky. For example, boron is in group 13. Here's boron, it's in group 13. The number in the ones position, it's not the number 1, the actual digit 1 is in the tens position. So it's the 3 that's in the ones position. Boron has 3 valence electrons. There's absolutely a pattern here. For us, the atoms that we're going to be working with, hydrogen has 1 valence electron, it's in group number 1. We're skipping all the way across over here to boron, which has 3, carbon has 4, nitrogen has 5, oxygen has 6, it's in group 16, it has 6 valence electrons, and our halogens in group 17, we're going to say that they have 7 valence electrons. The number of electrons in the outermost energy level, valence electrons. Finally, this is in contrast with the total number of electrons. As we get deeper into the unit, the difference between valence electrons, just the ones in the outside, versus the total number of electrons is going to be a thing. We can identify the total number of electrons that an atom has by looking at the atomic number. So whereas boron is in group 13 and it has 3 valence electrons, because it has atomic number 5, that means it has a total of 5 electrons. Just to say a different elements example, here's oxygen. Oxygen is in group number 16. That means it has 6 valence electrons, 6 electrons in the outside, but the total number of electrons in an oxygen atom corresponds to the atomic number, and oxygen has an atomic number of 8. So, we're going to be doing a unit with not very much math that has a really limited part of the periodic table that we're going to work with, and it builds off of these 3 ideas that we encountered once upon a time. Period, that's the horizontal rows, not as important as vertical columns. Valence electrons have a really big part to play in our work throughout the entire course of the unit. And as we get deep into it, the contrast between valence electrons and total number of electrons is something for us to be conscious of. And I hope that helps.